Thank you. Hello, everybody. All right. In the interest of time, we are going to just jump in. I'm going to ask a couple questions, and then if you guys are interested, I might give you an opportunity to ask a few questions as well. So to get started, you have heard that this is Bill. I don't think that Walmart needs any introduction. So instead of starting with, who is Walmart and what do you do, I thought that maybe Bill could start with also not his first AI rodeo, right? So what has changed with AI? Where are you today? What are the business problems and challenges that you're looking at? Just give us a level set of where Walmart is today.
Okay, so fundamentally, you'll always hear me talk about the fact that math and science hasn't changed roughly in 30, 50 years. What's actually changed is the technology around it that enables it. So given that, we actually have opportunities we didn't have previously. From a Walmart perspective, as well as most of the companies probably sitting in the room, the sheer volume of data is a challenge. I'm joking around saying that 10, 15 years ago, I had 1 gigabyte of data doing my first project and thought I was great because I had 1 gigabyte of data. Now, it's not uncommon for us to process 7, 8 terabytes of data a day through just one environment. So we have a significant amount of data. From a business challenge, it's how do we leverage it, how do we use it, how do we make it accessible, and that's obviously a big compute discussion and a big technology discussion.
Just to level set in the room, how many people are technologists? Okay, so we get a lot of technologists. Great. We can go technical. Great. All right, so you had mentioned terabytes in one location. How many locations are we looking at for data right now?
So it's an interesting question, the fact that there's different locations of data. There's where data is stored, there's where data is captured. So we have 5,000 stores in the US. We have more than that, obviously, worldwide. All areas where we generate data. We have websites where we generate data. From a federation or the data capture standpoint, that's where we stand. As far as where data sits today, we really sits in 3 big segments. SAM's International US is where the data sits, and then we go through that from a common governance and structure program.
Perfect. Okay, so that's where Walmart is today in terms of where the data is. I assume that the challenges haven't changed. You're still trying to deliver contextual, personalized services. You're still trying to do logistics and transportation, all the same challenges, right?
Yeah, same challenges they've been for 20, 30 years.
All right, good. There is one thing that's different, though. As I understand it, the two of you are working together on something called NVIDIA Rapids. Which is an acceleration set of software solutions for GPUs. I thought that maybe Josh could, since he is the GM of data science at NVIDIA, talk a little bit about what is Rapids and what you were trying to do with Rapids, just to level set for the audience. How many people have heard of Rapids? Let's start there. Okay, so we need some level setting on what Rapids is.
Absolutely. And so GPUs have been around for a very long time. They were kind of born out of graphics, then supercomputing, with the advent of CUDA, and then more recently, deep learning, AlexNet, cuDNN. As we've progressed through the years with the GPUs, one of the things we realized is they can do a lot of things. Data science is really just a parallel computing problem. When you think about your traditional Hadoop and Spark nodes, you distribute out large amounts of data to many nodes, and you do things in parallel. And so GPU is a great form factor for parallel computing. And what Rapids does is it does all the things that we've been doing for the last 20, 30 years just on the GPU. So it's an end-to-end collection of libraries to do data processing, machine learning, graph analytics, deep learning, and it brings it all together with simple interfaces that we all know, Python, and some other languages we're adding on. And so the whole goal of Rapids is really to change nothing, just to make it really easy to use and leverage all the speed and power of a GPU.
Okay, so, and this is open source.
Absolutely.
Okay.
It's a fully open source ecosystem.
All right. Now, the two of you are working together, which means that you're working with NVIDIA on an open source project. Can you explain to me why you wanted to do that, why you thought that was a good idea, and what you expected to accomplish out of it?
So 2 or 3 things. One, the power of Rapids is key in order to allow us to take advantage of the power of GPU. So from our perspective, we would actually like to use GPU in more areas. Right now we use it for forecasting, but we're looking to use it in logistics optimization, other areas as well. But in order to do that, we needed to work with the team on Rapids to make it more readily usable for others in the company. That's one. 2, we also believe that it actually is the foundation to allow GPUs to be used in other industries and other markets as well. And so we think that's a good thing to contribute to as well. So they're kind of the 2 main reasons. But from a Walmart perspective, it was about unleashing the power of it, and working with Rapids is key to making that happen.
Okay. And that's a little bit different in some ways because working with open source as a large enterprise customer, that might be counterintuitive. So you believe it's actually going to help you bootstrap the adoption of AI across the company?
Yes.
Okay.
Yeah. It'll make it more readily available to do. AI, and talking about GPUs specifically, is something that our customers and when I say customers, I mean internal to myself and the company, are adopting pretty quick. This actually allows us to solve problems we couldn't before. So that's where Rapids actually allows us to do that. That makes sense.
And so what we're seeing across a lot of companies is they have these brilliant data scientists and they want to solve a lot of problems. They fundamentally know how to solve the problems. They just don't have the compute capacity to do them within a certain timeline. And so what GPUs do is they accelerate the whole process so they can do more with less, and they can iterate more quickly so they can solve more problems. And we're just building the building blocks to make that easier for people to build these applications.
And so a real life example is we have 500 million combinations between store and product. Forecast for that would take weeks typically, but with GPUs it's something we can do daily. And so for us, it solves a critical business problem. At the same time, that was actually an outshoot of working with NVIDIA on Rapids that led to that project.
Okay, so let's dig into that a little bit because there are lots of different types of technology we could be looking at here. We could be looking at CPUs, GPUs, TPUs, VPUs, NNPs. Lots going on with the alphabet soup here. So why GPUs? You mentioned one use case where it was about speed. Any other dimensions that we should be looking at with GPUs and why you thought GPUs were a good choice?
Well, for us, there was two things. One, obviously the speed. Big factor for us, big form factor there. Second is working with NVIDIA and making it actually easily accessible and usable. You can have the best technology in the world, but if your data scientists can't use it, then it's actually useless. And so that was the usability by working with the team was critical, and then the speed aspect. Other options and how we can use it. I believe it can be used across the entire spectrum. Today, most companies use it maybe for imaging analytics and the machine learning. I actually believe it can be used also for the data process and the ETL, et cetera. Because if you don't do that, you'll never get to the data science. The value creation to data science, but you have to do all this data work first, and I think GPUs will play a big part there as well.
You mentioned the dreaded word ETL and data cleaning and data engineers. Work me a little more through that. How has it changed as a result of working with GPUs?
Again, back to sheer processing and speed and the statistics we see on that. If we're doing a forecast and maybe we have 10 different data sources for that forecast, and it takes us 3 weeks to run through the forecast, but now we can actually run through it in a day with GPUs and also bring in more data assets. I like to use forecast as an example because if you have weather in a forecast, it's always more predictive than not. So if you're predicting inventory in the store, if I have weather, local weather, I can identify what should be in that store much better than if I don't have weather. Well, you need more compute power in order to do that. So it is really a straightforward calculation of compute power. It allows us to bring in more data to be more accurate and do it faster.
So tell us a little bit about the other types of data sources that you're looking at.
We have, we have our own store data. What happens in the stores. We have what happens in logistics, where the product is in its own supply chain. You can look at outside data such as weather. You have customer preferences when they share those with us, things of that nature. It allows us to actually be more, hyper local or hyper personalized.
Yeah, we were talking earlier about the concept of football.
Yeah.
Tell us a little bit about hyperlocal and football.
So Retail 101 is if there's events local to a store, it'll actually have higher sales. So an example could be actually local events, sporting events, things of that nature, and sharing that into the forecast. That with weather, with shopping habits of that region, combined with the store's historical sales, you add all that together, we can get a very accurate forecast of what should be in that store. So that way, the product's on the shelf when the customer comes into the store. That's the experience we want. Customer comes in, the product they want is sitting in front of them on the shelf. So that's what we're looking for.
So another question about sort of the mechanics of how this gets done. So you have data scientists, and there are also business people that have problems. Organizationally, do you team those up? Do you have data scientists that are more aware of business problems? How do you think about that?
For me, I think it actually goes both ways. I think technologists have that business savvy, and I think business has to have technology savvy. And so my organization is typically the glue between the two. Mm-hmm. And we work with the business on their challenges and problems. We kind of walk through the realm of the possibility things such as GPU we can do. These are the problems we can solve today that we couldn't 3 months ago or 6 months ago or 2 years ago. And then we work with them on bringing that data to the table, sitting with the data scientists and solving those problems. That's how I've seen it be successful. That's what we're doing at Walmart. It's what I've done in my past life as well.
And I think that's really common as well. Even on the Rapids team, we have data scientists who their main role is to compete in Kaggle competitions, work with business people to solve pure technology problems, as well as the CUDA developers to say, when something is not as efficient as we would like from a computational standpoint, let's improve this kernel, let's improve this optimization, and then let's make sure it fits into the whole system of software that needs to get this out to the end user. Having this kind of 360 team really allows the ecosystem to grow really quickly, but also it allows usable software. I think that's really important, is to have the business people, the data scientists, as well as the system and kernel engineers working together.
Yeah. I would say there's a quote 15, 20 years ago around art plus science is how you get truly good solutions. The art being the business aspect of it and the science being the data science and the technology. The reality is more value is driven when you bring the two together.
Yeah, absolutely. And I think that it's only in understanding the business challenge that we can take all the data and really make something insightful and actionable out of it. So that's good. That's working. Tell us a little more, Josh, about this concept of the ecosystem around Rapids and what you're trying to accomplish, and what's been an aha moment as you've progressed? Because it's been how many months now? About 8?
Right. We officially launched about 8 months ago. We've been working with customers for a while longer than that. We've been working with Walmart for over a year. And so
Early adopter.
Early adopters always. The ecosystem is great. One of the things we realize is we can't build everything, nor do we want to. We really want to build this foundation, this platform, to allow this next generation of data scientists to do all the things that they've thought about, as Jensen says, in their lifetime. And so we want to solve the problems that people weren't able to solve. And so when we pair all these people together, we build this really great ecosystem. And so the same kernels that we write for our data frame library in Python can be used in SQL. And so there's a startup, Blazing DB, who wrote Blazing SQL. That's a SQL engine directly on top of Rapids. Our ML library is incorporated into a bunch of different startups and edge platforms. And one of the things that was kind of a nice surprise is even internally, we had a team who was doing stream processing. Most of Rapids was designed for batch processing, batch ML, so you can deploy models for inferencing, whether it's at the edge or in the data center. And they said, we could probably take this batch processing and just put it into our streaming pipeline. And we said, sure, go for it. And they came back a few weeks later, and they said, on our smallest GPU at NVIDIA, the T4, it's this little candy bar sized 75 watt GPU. They got a 10x improvement versus 24 cores in a server. And so they were like, this is perfect. We have a small watt GPU. We can just add it to our streaming pipeline. And now our pipes go from a certain size to 10 times larger with throughput. And that's directly to more efficiency, better monitoring, better performance of streaming analytics. And that's really what an ecosystem brings. The more people that are contributing back to a core platform allows the more rapid development of applications.
So one of the things we talked about is basically taking the old problems and doing them better. If you look at where you are today, you mentioned that there were 2 vectors you gauged your projects around. Maybe you could talk a little bit about those and how you see your AI work evolving within the organization.
Okay. Everything we do at Walmart is really focused on 2 things from a technology and analytics perspective. One is enhancing our customer experience, and the second is actually everyday low price. So everything we do actually has those 2 vectors. Will this project actually make our customers happier by making sure the product's on the shelf? Will it actually make their experience better? Will it actually help us reduce our costs and logistics so we can pass that on to the customer and price? So everything we do focuses on those 2 things. From an AI perspective and just analytics and data science in general, we feel there's huge opportunities to actually do that in the logistics area is one of the areas we can do that. Also in our inventory. We have great on-shelf availability now, but we'd like it to always be better. It's one of those things you always want to improve. Areas in our customer interactions as well. By doing some of the things we're doing in the stores today, we're freeing up time for our associates to spend more time with the customers to do things that a person can do with a customer, which is better customer service. Machine can't do that, a person can. So we like to free up time for our associates to do more of that. From an AI perspective, we're looking at every aspect of the company where we can apply it.
Got it. Okay. And does that mean that you're going to need more data scientists, or is the idea that by leveraging things like Rapids, you'll just be able to scale that more easily?
So this is a generic, non-Walmart answer, but in general, there will never be enough data scientists in the world to do what we need. So, and that's speaking for everybody in the room. So at the end of the day, we need to build solutions such as Rapids to make the tools available to others as well. I always say there's the A+ data scientist. There's only 10 of those, but there's probably 50,000 of the C+. We need to actually be able to enable tools to take care of to actually enable the 50,000 to drive value for us, for everybody. So to answer your question, we're going to need more data scientists, but at the same time, I think we need to make tools more easily available for them. Rapids is an example of that.
Josh, so we're obviously talking about retail, but can you give us some other examples of how this tech is being used in other industries?
We're seeing everything from healthcare, telecommunications, and finance using Rapids. There's just been some phenomenal work, especially in the banking sector. I think they've always been using GPUs for quantitative analysis. But by making it easier with Rapids, making it essentially more Pythonic, more people can use it. And so it just lowers the barrier. And so even from things from churn analysis, recommendation engines, what have you, we're seeing these really kind of just traditional machine learning problems expand, use more data, where something used to be a simple BI decision because that's they didn't have the computational power to do every use case they wanted. So some use cases get machine learning, some get just traditional BI. Now they can kind of go further down the pipeline and everything is powered by machine learning. And that's really exciting.
As a data scientist, I've spent the past 20 years of my life typically lowering the ability to develop a solution to meet the technology for implementation, for training, et cetera. That paradigm is flipped. Now we have things available to us that we've never had available before, and there's things we could do. Neural nets, they've been around since 1956, I think, but definitely commercially available since the mid-1990s. At the end of the day, there are very few were in use because the computational power wasn't there. GPUs make that available to us, and we can solve lots of problems we couldn't solve before.
Okay, so I'm going to ask you one more question. It's a two-part question. Then I'm going to go to the audience for Q&A. Okay. So the first part of the question is: you have a lot of data. You can now analyze that data rapidly. How do you get it back into applications? And the second question is: I know we talked about speed. Can you give us a couple of crunchy numbers about what you're sort of seeing in speed and where that matters?
So how do we get it back in applications? I'll address that one first, and Josh may want to jump in here as well. So typically when you're training the models, when you actually use more data intensive, when you actually execute it into application, it's a much lower footprint. You're only using the data that's used in the algorithm itself. So typically that's not as much of a challenge for us. And as far as getting it back into the application itself, that's where I also believe that GPUs can help us there as well. Today, it's typically CPU-driven data processing that's happening today in most legacy companies, which in itself is inherently slower. To kind of go to your second question, we've seen speeds in the neighborhood, depending on the type of data source, between 40 to 90%, 40 to 90 times faster. So I think it was 43, I think was the number on the HDF side, and 90%, 92 or 91 on the same source data types. So at the end of the day, that's a game changer. That allows us to do things that we couldn't do, or we might have just used BI for, that we created a pre-vision or a preview for, and now we just display in a report. Totally changes the game on what we can actually do.
And to extend that a little bit, Rapids follows the same traditional data science ecosystem, APIs, paradigms. And so, as he was mentioning, the 40x reading from HDFS, we integrate with traditional formats, whether that's Parquet, Org, Avro, CSV, JSON. We don't want to change anything. We don't even really want to change the APIs. So we follow Pandas, scikit-learn, NumPy. We want to make it as easy as possible. The things that data scientists come out of college knowing. Everyone knows Pandas. It's kind of ubiquitous. We just want to scale it, put it on GPUs. And so it really kind of plugs right into the traditional ecosystem, which lowers the barrier to put it into production. And so putting code into production has always been a challenge. So anything you can do to remove barriers is important.
Any differences in your thought between it being training versus inference in terms of what type of technology you'd be using?
No, and different from a different technology standpoint. The larger data lift is on the training side. That's when you're looking at your significant data lift, and then we're using GPU on that for the forecasting piece today. From an implementation standpoint on the inference side, to me, I don't see any reason why I wouldn't use higher performing GPU there as well. The previous session was IoT based, that's actually on the edge, heavily going GPU as well now, because in order for you to actually be able to make a decision in real time on the edge, you're not going to be able to bounce back off a cloud in sub-second time. So you still need the compute power out on the device or out on the edge. So it doesn't change for me from that perspective. I'm not sure, you may have a different answer, but.
No, and I think that's actually the value of the ecosystem
He
as well.
can't answer that question.
Well,
he's got the GPUs. That's not his question to
I think
answer.
I gave him.
But I focus on the data center side. I actually don't really think about edge or our embeddeds. And I think that's what I love about CUDA and why actually one of the reasons I came to NVIDIA, it just works everywhere. And so what we do in the data center, we can deploy it directly to our embedded side, and the same code just runs. It's all the same architecture. So it's pretty easy to move from data center, which I focus on, to edge.
And if you're changing the technology, then you have translation. You may have impacts to your algorithms. Most of it won't ever get implemented, et cetera. We see that to be fairly common. So.
Okay, we have time for one question. Who's got it? I'll go there.
I got a mic.
You got it? Okay, never mind.
Bill, you mentioned transportation and logistics is something that you can make progress on with these kinds of techniques. So what's something you can actually get as a business when you have more compute to use deep learning on your transportation and logistics infrastructure?
Yeah. When you're just looking at classic constrained optimization scenarios, things of that nature, given the sheer size of the data we deal with and the potential actions you can take, the scenarios are so large we can't run them on CPU in any amount of reasonable time to implement them. So we have to go GPU. Forecast was the same thing, actually. I said we have 500 million different combinations, and the sheer amount of data we run through that's obviously in the petabytes and terabytes. So at the end of the day, we couldn't physically do it, so we would actually have to dumb down the algorithms, which is what's happened for the past 25 years. The GPU and the pure computes allowed us to do things that we couldn't do before, which include more data and do it faster, try to shorten the timeline. We'd love to get the real time, everybody would, and we're hoping to go that direction.
I think we have time for one more question, or no? One more question back there.
That makes sense?
So Bill, you mentioned all the places you operate in, the 5,000 stores and so on, the logistics centers, the website, you have Jet, you have store number 8, you have the IRL store, you have R&D all over the US and the world. And those are all and you have training and inference and so on. Those are all places where you might have GPUs and other compute infrastructure. How do you go about managing all that infrastructure, and whose responsibility is it typically?
So the management of the infrastructure in a company is under Clay Johnson, the CIO. And so his organization manages the infrastructure. We actually decide on what technology we're going to use, typically more use case driven. At this point in time, we're looking to expand GPUs into other areas, but it's typically more use case driven. You were talking specifically about some of the R&D, intelligent retail lab, things of that nature as well. They're almost entirely GPU driven, those shops. So Clay Johnson's one that runs at our CIO, and he manages infrastructure. The business use cases through my organization, as well as other data science organizations, are the ones that decide what's the use case need. Is it a GPU, CPU type use case?
All right, I think with that, it is a wrap. Thank you very much. Round of applause for Bill and Josh.
Thank you.